Well, we've seen some examples of supervised learning, specifically regression and classification. But what about unsupervised learning? Now, in unsupervised learning techniques, you don't have a known label with which to train the model. But you can still use an algorithm that finds similarities in data observations in order to group them into clusters. Suppose, for example, our health clinic has a website that contains links to articles in medical and healthy lifestyle publications. Now, I might want to automatically group similar articles together. Or maybe I want to segment our study participants, and we could categorize them based on similar characteristics. There are a number of ways we can create a clustering model, and we're going to look at one of the most popular clustering techniques, something called k-means clustering. Now, the key to understanding k-means is to remember that our data consists of rows of data, and each row has multiple features. Now, if we assume that each feature is a numeric value, then we can plot them as coordinates. Now, here we're plotting two features on a two-dimensional grid. But in reality, multiple features would be plotted in n-dimensional space. We then decide how many clusters we want to create, which we call k, and we plot k points at random locations that represent the center points of our clusters. In this case, k is 3, so we're creating 3 clusters. Next, we identify which of the 3 centroids each point is closest to, and assign the points to clusters accordingly. Then, we move each centroid to the true center of the points in its cluster, and reallocate the points in the cluster based on their nearest centroid. And we just repeat that process until we have nicely separated clusters. So what do I mean by nicely separated? Well, we want a set of clusters that separate data by the greatest extent possible. To measure this, we can compare the average distance between the cluster centers and the average distance between the points in the cluster and their centers. Clusters that maximize this ratio have the greatest separation. We can also use the ratio of the average distance between clusters and the maximum distance between the points and the centroids of the cluster. Now, another way we can evaluate the results of a clustering algorithm is to use a method called principal component analysis, or PCA, in which we decompose the points in a cluster into directions. We represent the first 2 components of the PCA decomposition as an ellipse. The first principal component is along the direction of the maximum variance or major axis of the ellipse, and the second PCA is along the minor axis of the ellipse. A cluster that is perfectly separate from the first cluster shows up as an ellipse with the major axis of the ellipse perpendicular to the ellipse of the first cluster. Now, if our second cluster is reasonably well, but not perfectly separated, then it will have a major axis that's not quite perpendicular to the first ellipse. And if the second cluster is quite poorly separated from the first, the major axes of both ellipses will be nearly collinear, and the ellipse may be more like a circle because the second cluster is less well defined.